Now lines as such in the coordinate system are something which is a starting point of the conic sections. Now lines can be of three type. One is which is horizontal to x-axis, something like this. Another type of line is vertical or the parallel to y-axis, and third is oblique, which can make an angle theta with the x-axis. Now the equation of the line which is parallel to x-axis will be equal to something like y is equal to a constant a. This line will be parallel to x-axis. Now a line which is parallel to y-axis, the equation will be something like x is equal to b. However, a line which is making some angle theta with the x-axis is something like y is equal to mx plus c, where m is the slope and c is the y-intercept. Now there are various conditions over line. You can draw another line which is, say for example, perpendicular to this line. You can find the equation of another line which is parallel to this line. So what are those conditions? Number one, a line is perpendicular to this line should satisfy this condition. Suppose the slope of this line is m. Slope of another line is, let's say, k. So line which is perpendicular to this is y is equal to, say, kx plus c, or maybe c1. Now what is the condition? If this line is perpendicular to this, that means k into m should be equal to -1, right? So whenever you want to find a line which is perpendicular to a given line, then the slope should be such that it is, if you multiply the slope of the perpendicular line and this main line, that should be -1. Now what about a line which is parallel to this line? Now a line which is parallel to this line means the slope will be same. So if this line, same line is parallel to k equal to y equal to mx plus c, that means k should be equal to small m. So that is the condition. Using these conditions, one can find a line which is perpendicular to this line, given line, or parallel to given line. That's one. Second aspect of the line is that suppose you have a line which is confined between these 2 points. Let's say the coordinates of first point is x1, y1, and coordinate of second point is x2, y2. Now what will be the coordinate of a point which is between these 2 points? Say somewhere here, right? Now the coordinate of this point will be x1 plus x2 by 2, comma y1 plus y2 divided by 2. That's the coordinate of the point which is at the middle of this line. Now let's take another case. Rather than taking the middle point, suppose I take another point, let's say somewhere here, which divides this entire line into the ratios m1 and m2. That is, this portion and this portion I am taking as m1 is to m2. That's a ratio of this particular point. Now what will be the coordinate of this new point? Now the coordinate of this new point, let's say x bar and y bar. So x bar will be equal to m1 x2 plus m2 x1 divided by m1 plus m2. There's an x coordinate of that particular point which divides the entire line into the ratio m1 and m2. What will be the y coordinates? Y coordinate will be equal to m1 y2 plus m2 y1 divided by m1 plus m2. So that's a y coordinate. Therefore, you can always find a point between a line which is maybe dividing the line into the ratio m1 and m2. Now suppose there is a point which is outside this line. Now a point which is outside this line, you can change something like here there will be a negative sign, that's all. Almost the same formula will work for a point which is outside the line and dividing this line into a ratio m1 is to m2.